Hey guys, so this is the graphic portion of the knot problem, and so let's try solving. So determine the intervals where f is increasing and decreasing based on the graph of f prime. So this is actually f prime of x graph here, and so basically this is where f is less than 0 and this is where f is greater than 0. Okay, so what we have here is at -3. So you see, what am I doing, guys? I'm sorry. So -3, we have basically an interval because it's like in the x value, or in the x. I don't know how to say it, but yeah. Okay, and we have 1/3 also here, huh? I see that. Okay, I'm trying to think here with the graph we have. So what I would say is that I would say -infinity to -3 union with 1/3, 1 and 3, right? I think so. Oh, yeah. Because f prime is actually greater than 0, right? Now, with decreasing, we have f is decreasing at -3 and 1, and then union, we have 3 and infinity, because f prime is less than 0. And this is how you solve this problem. Hey guys, so this is the numeric portion of the GNAW problem, and this problem consists of a table, and we're going to be solving from the table. So let's read the question. So a hot air balloon is launched into the air with a human pilot. The twice differentiable function n models the balloon's height measured in feet at time t measured in minutes. The table above gives values of the h times by t and the vertical velocity of the balloon at selected times by t. So as you see here, let's try understanding this. So the table consists of the minutes, the feet, or the height of the feet, and the velocity. So for 5 less than equal to t less than equal to 20, must there be a time t when the balloon is 50 feet in the air? So let's look at our graph here. Okay, so it says between 5 and 20. So it'll be like between right here, right? So it's around like the 15 portion. It's in the middle of the portion of the 15. So what I do is that I say that, okay, this is actually the intermediate value theorem, because of how when you look at the graph, and when you put the points in, it'll be like different than the mean value theorem. But in this problem, it's the intermediate value theorem. And from there, let's try solving. So let's try finding, must there be a time t? I think there should be. So like I'll say that h5 equals to, well, 5 equals to what? 40, less than equal to 50, less than equal to h times by 20. And so we're looking at 50 feet, which would be right here, h times by 20, and h times by 20 equal to 65, because we're looking at the feet, right? We're focusing on the feet because it's saying 50 feet times t when the balloon's 50 feet, okay? And yeah, I think this is it. Now I say yes. How I found it is because talking about 50 feet. So between 40 and 65, we have 50 feet, and 465 between 50 feet is in the middle, right? It's not. If it was like 70, then we would say no, because it's bigger than 40 and 70. It's bigger than 40 and 65. So it wouldn't make any sense. And this is your answer for this problem. Alright, so this is the algebraic problem of the GNAW problem, and we're going to be solving this, okay? So use the function f of x equals to negative x squared plus 3x plus 10 to answer on the interval 2 and 6. What is the average rate of change? So we're going to be using the formula f of b minus f of a, b minus a, and you will see the, I'm sorry guys, but let's just start solving this. We're basically just going to be interpreting the interval to the formula and then solve from there. So let's do f of 2 equal to negative 2 squared plus 3 times 2 plus 10. F of 6 equal to negative 6 squared plus 3 times by 6 plus 10. Oh, I forgot to solve this. Okay. So 4 plus 12 plus 10. I think... Oh, 4 plus 6 plus 10. That would be... I think I approximated to 12. And then 36. This would be basically negative 8, I'm guessing. Yes. Now, let's use a formula. So let's use f of 6 minus f of 2. 6 minus 2. 6 minus 2 is 4. And then we have negative 8 minus 12. And negative 8 minus 12 is together it would just be negative 5. Okay, and this is your answer for this problem. Alright, so this is the verbal problem of the GNAW problem, portion. So let's start with this question. Can you find the x coordinate of the absolute maximum and the absolute minimum? Well, let's solve this. Okay. So what we have here is we have a lot of up and downs, you see. So if you think about it, it's going from positive to negative, okay? Positive to negative, right? So from here to there, I really think this is like the negative, positive, I'm sorry. And then this is another point right here that could make also another sense, right? My marker is dull. And so I think that this is the maximum because since it's going down here, and then the minimum would be going up right there. So let's try making this as a word problem. F of x has, oh, why did I do an equal sign? F of x has absolute maximum at x equals 1 and absolute, oh, I spelled it wrong. Absolute minimum is at x equals 3. And this is your answer for this problem.